Hello everyone and welcome back to another Sci-Friday. My name is Brandon. I'm the Education Director here at the Grout Museum. Coming back to you with a really cool experiment, and this one involves sound waves. Now, all of this stuff that I'm going to show you for this experiment is stuff that you should have at home, with the one exception of maybe is the laser pointer, which is something you might have to get, but they're pretty easy to get. It doesn't have to be a super powerful one or anything like that. But what I'm going to do today is I'm going to show you what sound waves look like. And this is also kind of going to explain how the ear works, like how your ears work. But let's go ahead and show you the experiment first, and then like usual, I'll explain kind of how it worked afterwards. The setup I have here includes this laser pointer, which points down to this mirror that I have on top of this contraption here. And that laser pointer is pointing right onto the mirror, and it's bouncing up onto our wall over there. But the rest of it is literally just a plastic cup that has the bottom cut out and a rubber balloon stretched over it. And then it's on top of a speaker. And so this is a Bluetooth speaker, but I'm gonna hook it up to my phone and kind of show you how that works. I have it taped to the speaker so it doesn't move. You do not need to have it taped to the speaker. You can just hold it on the speaker if you want to, but I want to have my hands free. This is the same reason I have the laser pointer on this contraption. You can just hold the laser pointer and point it at the mirror. That works too. So we're going to go ahead and hook up, either you can hook up a phone or a computer, anything that you can find a tone generator on. So that's what you're looking for, is a tone generator. And then you can set the different frequencies, and I'm going to go ahead and show you this experiment and tell you what frequencies I'm going to be using as we do them. So this is our laser without any sound going through the speaker, without going through our setup. It's just a regular, it's sort of elongated dot, but that's because of the way it's reflecting off the mirror. It gets a little distorted. Now I'm going to play it with 100 hertz as the frequency with just one sound. And so you can see it has changed the shape of that laser. It takes it from this into almost like an oval kind of shape. So this is what the laser light would look like with 100 hertz and 200 hertz, two different sound waves running through it. It doesn't look like that oval anymore. Now it kind of looks like a V or a U shape. And that's because we added the second layer of sound. But what's really interesting is you can change it, and instead of doubling it, I'm going to put it to 201 and 100. So it has two sounds still, this time at 100 hertz and one at 201 hertz. So just 1 hertz difference on that second one. And you can see it almost looks 3D, like it's rotating. Like it's a rotating shape. And if I increase my frequency to 202 and 100, it rotates faster. So as I increase the frequency, I get this faster rotation. Now it's at 204. And the same thing happens if I slow it down. It just goes in the opposite direction. The reason it does this is because when you perfectly double the sound, they do what's called, they harmonize. They are basically, they match up at some of the same points. And so they end up making a different shape that is stable. But if you make them just slightly less stable by changing one of them by 1, so to 201, you end up with this rotating shape because they're not perfectly in harmony anymore. What you saw there was that the laser looked like it was not just making a single point like a laser normally does. It looks like it was making shapes. Now, you may think that that means that the laser is being spread into those shapes, but the laser is actually traveling along those paths. And it's making that whole shape, but it's making it so fast that you can't see the laser move. So it looks like one whole shape, when really it's just one dot moving around really, really fast. Now, the reason this works is that the speaker here, as it creates the tones, it sends sound waves up through this cup. And we use this cup because sound waves normally go outwards. As they get away from their source, they get bigger. What the cup does is it makes them narrower, and then it gets to this top where we have this balloon, and this balloon acts kind of like a drum skin. So it kind of catches those reverberations and bounces. As it bounces the mirror. And as the mirror bounces, it makes the laser do all those different shapes. It makes it trace all those different shapes. And this vibrates so quickly that you can't actually see all the vibrations that are happening. They're happening so fast. But what's really neat is that this is exactly how your ears work. Now think of this speaker as the sound coming into your ear, whatever sound it may be. You hear your sister, brother, your mom talking. That sound goes into your ear canal, which is the cup. And then inside of your ear, you have an eardrum, which is what this mirror or the balloon is representing. And so this is your eardrum. And as those sounds hit your eardrum, they bounce around. And instead of a mirror on the inside of your ears, we have these 3 little bones that do the same thing as the mirror. And they actually bounce around and they shake up all the fluid that's inside of your ear. You have fluid in your ear. It's normal, it's okay. But it bounces all that fluid around, and those fluids then hit all these little hair cells inside of your ear. And those cells are then translated into electric energy, which then goes to your brain and tells you what that sound is. That is our experiment for today. I want to thank you guys for coming by. If you do this at home, please feel free to tag the Grout Museum in your experiment. I'd love to see you guys doing this at home. That'd be really cool. See your setups and see how you got it to work and the different frequencies maybe you use to get cool shapes on the wall. And thank you for coming and have a good day.